shared some questions. Do you see the questions? See the questions? Are you able
Yes.
to see the screen? Yeah. Okay, so now
Yes,
we'll
sir.
discuss about next topic, functions, and what is the significance of functions, and we'll try to understand the general idea about functions. And you already studied functions in school also in 8th or 9th standard, right? So the natural question is, what is function? Do you see the functions in practical life? Did you came across such functions, right? And why to study the functions, right? So uh, did you see functions in practical life?
Yeah,
For example,
the whole roll number system can be considered like a function where you put in a number and you get a student sort of.
pardon, cannot hear you properly.
The whole roll number system can be considered like we give each student a roll number. Like you can just calculate a function where you're putting a roll number and you get a student.
Right, very good. So what is your name?
Well, these things are nothing.
Okay, so what he said, ki you have two sets. I have set X, set of students from FYBSc A division, right? And what is set Y, set of numbers, right? So set of numbers. So suppose my set is set of students, so S1, S2, S3, these are students. And what is my set? Set of numbers, 1, 2, 3, and so on. Whatever is the number, that is not an issue at this instant. So what I will do, I will assign S1 as some roll number, suppose 10, right? I will assign student some. So these are names of student. S1 is name of one student, S2 is name of another student, and S2 I will assign some 20. For S3 I will assign roll number 5, right? So uh, if we assign roll numbers to the students, then it's a function, right? So why it is a function, and what are the properties of function? So this is the assignment. We are assigning, right? We are labeling something. We are assigning roll numbers. We are assigning chairs to the delegates, right? If guests come for some function and then we assign chairs, this chair is for this person, that chair is for particular person, so we are assigning, right? So we are mapping, right? So there is a kind of mapping. So, and therefore what is a formal definition of a function, right? So what is a formal means classical or mathematical definition, so that this definition will fit in any case, right? At any instance, this definition is useful. So we are assigning. Assigning is what? So look at another thing. Suppose I have a set A. A, B, C, and B is 1, 2. So see, why we want to understand, and I expect that you will tell me the definition, right? So I will assign A with 1 and I will put them in a pair, right? Because I am assigning A with 1 and I want what I want a function from A to B. A to B means I want to assign elements of A, that is want to assign A with in B, right? So please keep your mic off. Somebody has kept mic on. So what I want function from A to B means I want to assign elements of A with elements in B. So I will assign element of A with element of 1, right? Now, as the previous example, if you look at set of students and set of numbers, and I am assigning student with some roll number. Now, can I assign in this case, there are some restrictions. So I cannot assign same roll number to two distinct students, right? I cannot assign same roll number to two distinct students. But in some situations, for example, we have classrooms, right? So we have classrooms and students. We have two sets. Okay, let me write in another way. So X is set of students and suppose C is set of classrooms. Then what I will do, I will assign classroom to the students. In this situation, what is the difference? Do you understand? Is it clear what I...
Yes, sir.
Yes, sir.
So many students can be assigned with same classroom. That is possible in this case,
Hmm.
right? Is it clear?
Yes, sir. Yes,
But
sir.
many students cannot be assigned with same roll number. That is not possible. But in this situation, more than one students can be assigned with same classroom because, for example, all the students from A division can be assigned with same or must be assigned with same classroom because there is no they must have same classroom, right? All students from B division will be assigned with same classrooms. So therefore, if you have all the students from A division, they will be assigned with some classroom C1. All the students from B division, right? There are many students. There are many students they are assigned with some classroom C2. Okay, but what is a common thing among these two situations? What is a common thing? What is a common thing? If you look at, see, okay,
Assigning.
assigning, we are assigning basically, but more then after that, what is a common thing? Something is uncommon, like the one student, so no two student cannot be assigned with same roll number, but here two student can be assigned with same classroom, right? That is a distinction. But what is a common thing?
One student cannot be assigned to two things.
Right. So one student cannot be assigned with two roll numbers because otherwise the system will collapse. And therefore one student cannot be assigned with two classrooms. Right. There is no student who has two distinct classrooms. This is a common thing, right? Same member in first set cannot be assigned with two distinct objects in second set. Correct? So now I want, so this is a main characteristic of function. So I want to assign each element of A with an element of B, right? Each element. So I will assign A with 1, I will assign B with 1, and I will assign C with 2. Is it an assignment? First of all,
No, sir.
why it is not an assignment? Because I have assigned A with 1, B with 1, and C with 2. No problem, because I can assign A with 1. I can assign, so two members A and B are assigned with same member 1, correct? And C is assigned with 2. So each member is assigned with some member, and the member, so A is assigned with 1, and 1 is a unique member. 1 is unique member. So this mapping or assignment is a well defined. Well defined in the sense what? Ki whatever we are going to assign, it should be well defined. Suppose in previous case, suppose S1 student is assigned with two distinct roll numbers. S1 is assigned with 7 as well as 10. Is it a well defined assignment?
No.
Right?
No.
Because which roll number should be printed on his mark list? For mathematics, I will consider 10, and for physics, somebody will consider 7. Then the software will not work, right? Because software will not accept marks of such students if this particular student has two distinct roll numbers, right? Or logically, many students can have same classroom, but if you assign two distinct classroom to division A, suppose C3 and C1 is assigned to division A, then what will happen? Suppose I assign same two distinct classroom to same class. What will happen? And suppose there is a mathematics lecture at 1 o'clock. What will happen? Logically, see, we are talking about logic. Mathematics is all about logic. So logically, what will happen? There will be chaos, right? You understand?
Right, sir.
So some students will go in C1 and some student will go in C3 because there will be lots of confusion. Because they will say that we are assigned with C1 and C3, so where to go, right? But you know that all A division is assigned with C1, then definitely all will go in C1 and there is no chaos, no confusion. Right? So this is a well defined. So whatever assignment we are doing, it will be well defined. Anywhere, anytime, it is irrespective of subject, it is irrespective of division, whatever. Once you make assignment, it is a well defined. So that we want, that we expect. And one more thing, every student must be assigned with some roll number, or every class must be assigned with classroom. Right, that is also necessary. Suppose some class do not is not assigned with any classroom. What will happen? Does such college exist? Does such system exist? If for particular class there is no classroom at all. Do you understand? Or some student do not have is not assigned with any roll number. Is it possible?
No, sir. No.
Right. Therefore, what is the main characteristic we observe here? Ki every member of A must be assigned with some member of B, right? Right. So it may happen that in college some classrooms are vacant. No class is assigned with classroom. That is not create an issue. You understand this?
Yes, sir.
So some classroom might not have any class assigned with, so that is not an issue. It will not create any issue. Therefore, it is not necessary that every member of set B is assigned with member of A. Not necessary. Or if you look at the set of numbers 5,000, 6,000, and in college suppose there are only 5,000 students and 6,000 number is available in Y. No problem if 6000 is not assigned with any student. Number 6000 or 6005 or 6050, this particular roll number is not assigned with any student. No problem, that will not create an issue because there are infinitely many numbers available. Right. So what are the important things so that our mapping is well defined, assignment is well defined, right? Do you understand what are the important characteristics? Every member of first set, right? Every member of each member of first set is assigned with what?
Some member of
Member
set
of
B.
Some member, and
B.
that member must be unique, right? That member must be unique. If two students cannot have distinct roll numbers, or two same class cannot have two distinct classrooms. You understand the image? You can imagine the situation. If that is necessary, which is what is the necessary? Every member in A must be assigned with some member in
Some
B,
member
and that
in B.
member is that member must be unique. That means if A is assigned with 1, then again A, we cannot assign A with 2. Otherwise, there is a confusion. That mapping, that assignment will have a confusion. Correct? And we are assigning is we are pairing. We are making pairs of elements A with elements in B. But what are the pairs? What are the pairs? We understand we are assigning A with 1, we are assigning B with 1, and we are assigning C with 2. So we are making pairs A comma 1, B comma 1, and C comma 2. And if we consider all these pairs together, if we consider all these pairs together, A comma 1, B comma 1, C comma 2, so this complete set of pairs, this set gives us some information, definite information. Am I right?
Yes, sir.
So this set of pairs gives me some definite information. Key A is assigned with what, B is assigned with what, C. So every member of A is assigned with some member, and it is assigned with unique member. So this set gives us information. But what is such set is called by our previous knowledge?
Yes,
What such set we called in our previous discussions?
relation.
Relation. It is a subset of, this is a subset of A cross B, right? So this is the relation. That is the important point you should observe. Suppose I take A comma 1, A comma 2, B comma 2, right, and C comma 1. So now is it a proper assignment? Is it a proper assignment? Is it a
No,
proper,
sir.
right?
No,
Because
sir.
Sir.
no, A is assigned with two distinct objects. A is assigned with this as well as this, and B is assigned with 2. So what is the problem? Problem is A is assigned with two distinct objects. That means student A is assigned with two distinct roll numbers. That is a problem. So this is not a proper assignment, right? This is not proper assignment. So this is not this doesn't give definite information, right? And therefore now we want to make a definition of formal definition of function. Formal definition of functions. Now can you tell me what should be the formal definition of functions? So,
So can I tell?
yes.
We can say that a function is a relation from A to B such
uh,
that each and every element of A has an unique is related to an unique element in set B.
Very good, right? So from previous discussion we can understand what should be our definition of function. So let A and B be non-empty sets. A function from a function. Okay, let me a function R set A to B is a relation. Okay, let me make it proper. A function from set A to B is a relation R such that for each x in A there is unique. There is, so these two words are very important. Which two words? For each x in A there is unique y in B such that the pair xy is in relation R. So here two things are very essential. For each x in A there is unique y in B. There is unique for each x in A there is unique y in B. That means for every student for each x, every student is assigned with unique roll number, or every class is assigned with unique classroom. Right? It should not happen that some class do not have classroom or some student do not have a roll number. Right? So these two words, what is the characterization of function? These two words only. For each x and for each, there exists unique. Fine. So, okay, let me example. So let A is equal to A, B, C. B is equal to 1, 2, 3, and I will look at R1 is A1, B2. Is it a function?
Yes, sir.
Is it a function?
No, sir.
No. Why? Which condition fails?
C.
Each x.
For each x, right? For each x in A. So for example, for C, x is equal to C. It is not assigned with any element in B. Right? So for each fails. Now A1, B1, C1. Is it a function?
No, sir.
Why no?
No, sir.
For each is first
Unique.
condition.
There is
For
no
each
unique.
first
It is a
condition
function.
for each x, this condition is satisfied.
Yes. Yes, sir.
Right. So A is assigned with something, B is assigned C. So for each. Now unique. Now think about unique. So A is assigned with what?
1.
And A is assigned with
1.
unique. A is assigned with
1.
unique element.
Yes, sir.
No doubt. B is assigned with unique element.
No, sir.
B is assigned with unique element. B is not assigned with one more element. Right. For example, if you assign classroom to class, right, then every student is assigned with every student from A division. If you have A division and you are assigned with classroom C1, then every student in this classroom is assigned with same classroom, right?
But
And
sir,
this,
in case of roll numbers, this case is fails.
no, that is not an issue. In case of roll number, what are our necessary, what are the requirements, what are the important conditions to be function for every element in A? This first condition is satisfied. Forget
Yes,
about
sir.
anything else. Second condition, unique. Now look at particular element A. A is assigned with 1. Is A assigned with somebody else? Another
No.
element?
No,
No.
sir.
A is assigned with unique element, which is 1. B is assigned with unique element, which is 1. C is assigned with unique element, which is 1. So both of the conditions are satisfied. You understand?
Yes.
Right. So only think about these two words, each and unique. Now let us see another example, then you can understand it better. A 1, B 2, C 3. Is it a function?
Yes, sir.
Yes,
Right?
sir.
Yes, sir.
Yes, sir.
This is a function. A 1, A B 2, C 3. Is it a function?
No, sir.
No, sir.
No, right?
No, sir.
Because what is the difference between R2 and R4?
A single element A is assigned with two elements in B.
Right. So single element A is assigned with two distinct elements, and therefore, what is the proper assignment of A? That is not clear, and therefore this is not a function. Right. So for every element in A, that is this first condition is satisfied for each, but unique element in B, that fails, right? For example, for A, there are two distinct possibilities. So this is function, correct?
Yes, sir.
So now the definition is clear.
Yes, sir.
Yes,
So
sir.
note that function is like a gun. Remember this. Function is like a gun. What happens with gun?
A
Suppose you
single
have a
gun
bullet,
has many bullets.
right? So you have bullets, set of bullets, and set of points in space where you can fire bullets. Right. So this is a set of bullets, and this is set of points in the space where you can fire the bullet, right? So I have bullet B1, B2, B3, B4, and so on. I have bullets, and I have various points in the space. Whatever you can say, you can say that suppose you are learning shooting, so then you have a plain sheet, right? And points on the plain sheet where you can fire the bullets, or you can say that the set of points in the space where you can fire the bullets. So that is not an issue, whatever is the set. But now you have a gun here, and so my drawing is not very good, so you can understand it. So you have a gun. So if you take a single bullet, is it possible to fire single bullet at two distinct points?
No, sir.
Right?
No,
You
sir.
cannot fire single bullet at two distinct places. But it is possible that you can fire many bullets at same point.
Yes, sir.
This is not possible, but you can fire many bullets at same point. This is possible. And that's why function is like a gun. So no problem. All students in A division are assigned with same classroom. That is not an issue. That is a definite information. Ki all students are assigned with classroom C1, So everyone will understand, and this is a definite thing, right? And
Yes, sir.
when you think about function, just think about gun. You cannot fire same gun with at two distinct places, same bullet at two distinct places. You may fire many bullets at same, and if you have a gun and if you have bullet, you can fire every bullet. There is no bullet key, this bullet cannot be fired by this gun. There is no situation, right? So you can fire every bullet, and this particular bullet is fired with unique point. It may happen that another bullet is also fired with same point at same point, so that may happen, but that point is unique place, unique position, right? It may happen in some movies you can fire same bullet at two distinct points, but that is not the real world, right? That these things are not real. In real world, what is a function? So is it clear? The idea is clear.
Yes, sir.
Yes, sir.
So let us go ahead. So now we want to make it more formal. So if a relation, okay, I would like to ask one more question. Is every relation a function? Is every relation a function?
No, sir.
No, sir.
No, because we have just seen that there are relations, right? So R1 is a relation, am I right? R1 is a relation in this example,
No, sir.
Yes, sir.
right? R1 is a relation, because what is a relation? Relation is a subset of A cross B. So R1 is a subset of A cross B. So R1 is a relation. I am not saying it is equivalence relation, right? I am not saying equivalence. It is a relation, but it is not a function. So relation may not be function. If let me make, if R is a relation from A to B, then it may not be. Maybe or may not be, right? Function. If R is a function from A to B, then can we say that R is a relation?
Yes, sir.
Yes, sir.
Yes, sir.
Then
Yes, sir.
R is a relation from A to B, right? So therefore, relation may not be function, but function is definitely relation. Correct?
Yes, sir.
Now, if relation R from A to B is a function, then then it is a subset of A cross B, right? So it is a subset of A cross B, and a function is generally denoted by the symbol or notation f. So the notation for function we generally use as f. So now if f is a function from a to b and xy belongs to what? F. Xy belongs to f. Then, right? So do you understand? F is a function, means it is a relation, and what are the members? Members are x, the pairs. Then we say that y is the value of f at x, and we write it as fx is equal to y. So if f is a function and then means it is a relation, so the pair xy is in f, means we say that the second component is a value of function f at x, and we write it as, so if f is a function from a to b, we write it as f is function from a to b. So henceforth we'll use this kind of notation. See, what does it mean? F is a function from a to b. So here set A is called as domain of f, and set B is called as
Codomain.
as codomain.
Codomain.
So A is called as domain, B is called as codomain because it is function from A to B. The set FA is equal to the values of elements in A. Now what can you say about this set FA? What is FA? The collection of value of function is a subset of what?
Codomain.
Codomain. So it is a subset of B and is called as what it is called?
Range.
Range
Range.
of F. So suppose you have a gun and you have bullets. Then every gun has its range. How far it can fire the bullets, right? So if you have bullets and if you have gun, and then how far it can fire the bullets. So this particular thing is a range, and yet every point you can fire bullet inside this. You may not fire bullet outside this range. So this function. Right. So one more thing we should note that if y if y belongs to b and x belongs to a, such that y is equal to fx. Y is equal to fx means what? Y is equal to fx means what? Y is the value of function at x. Then we
हमेशा एक डायलॉग मारते रहता है, छोड़ना
we
पकाऊ है सर है
we say
बोल रहा
that
गन की होती है, हमको तो पता ही नहीं था भाई.
we say that we say that y is the image of x under f, right? So y is the image of x under f. Image means what? If you project an element in A, right? So if you project an element x from A and it will land in here. So what is here? Y. Y is fx. So right. So corresponding element in B. Y is a corresponding element in B. So it is a kind of projection, right? We are projecting this element in A to some element in B, which is value of f at x, and we can say that it is image of x under f, right? So under this function f. Fine. So y is image of x under f, and x is called as
Pre-image of y.
pre-image of x in A under f. So we are talking about function f. So preimage x is called as preimage of uh, preimage of y, right? Sorry, preimage of y. So x is called as a preimage of y in B under f. So we write it as, so it as x is equal to f inverse y. So if you apply the inverse process means what happens ki x f sends x to y, right? That means f assigns x to y, and if you follow the inverse process, the y corresponds to x, right? But that inverse process is a difficult or is different thing that we'll discuss later on. But you can the two words are important, ki y is image of x under f and x is preimage of y under f, right? So there are different kinds of the different kind of sets, and then different types of functions are there. So we want to understand in general sense ki whatever you are set and whatever are functions. So for example, if I define, now define means I am defining a function or I am defining a relation. So I am giving proper relation among two elements. To define a function f from set of real numbers to set of real numbers by f of x is equal to x, right? So I define a map. I am mapping x with x. Is it a function? When I am saying function, so but is it a function basically?
Yes, sir.
Right? So it is a function because you choose any element from domain R, you can assign unique element, right? For example, if you take 500, then 500 is assigned with 500 unique member. 500 in domain is not assigned with some more than one elements, so it is a function. So answer is S. So this function is called as an identity function. Identity function. So identity means what? It maps element to itself, right? Element goes to itself. 2 goes to 2, 3 goes to 3, 1.5 goes to 1.5. So you choose any real number from the domain where it is assigned. So x is assigned with x. So this is again a symbol used for assignment. X is assigned with x. So this function is called as identity function. So definition. So let A be a non-empty set a function f from A to A defined by fx is equal to x for all x in A. So every element is mapped or assigned with itself is called as an identity function. So this function is called as identity function. So can you tell me one more example of identity function other than which we uh, defined before? Right? Suraj Joshi. Is there any Suraj Joshi?
Yes, sir.
Can you tell me one example of a function, identity function?
Mm. Yes, sir. We can take an example. If f of x is equal to any constant like phi, then the graph will be a straight line parallel to x-axis.
But it is not identity function. You understand? Identity function means what? X goes to x, 5 goes to 5, 3 goes to 3, 7 goes to 7.
Yes, sir.
Right? Do you understand the difference between general function and identity? Identity function is a special type of function. So, okay, if I take, just we defined here,
Sir,
if I take A, yes.
is identity function a reflexive relation?
What is reflexive relation? Yeah, you can say that. Very good.
Okay.
So if I define f from A to A, fx is equal to x, right? If I define this function, x goes to x. So therefore, where A goes to A, where B goes to B, where C goes to C, right? That means A is mapped with A, B is mapped
Yes.
with B, and C is mapped with C, right? So identity function, you can say that it is a reflexive relation. This is
Okay.
one characterization. Very good.
Thank you.
So this is identity function. Is it clear now? So x goes to x, or if I define function from natural numbers to natural numbers and f of x is equal to x. Identity means what? For example, what is f of 2 is 2, f of 3 is 3. Every element goes to itself. Fine. What Suraj said, look at another example. So define f from natural numbers to whatever is real numbers, for example, f of x is equal to 5 for all x in n, right? So what can you say about this function?
Sir, it is sequence.
With any value of x, we will get it as the value as 5.
5, right? That means every real numbers, for example, f of 1 is 5 because every x has image, same image 5. So f of 2 is equal to 5, f of 3 is 5, and so on. And therefore, uh, you vary elements in domain every time you are getting same image. So this is called as a constant function, right? So constant function. And therefore, what is the formal definition of constant function? So let A, B be non-empty sets. Right, so we are talking about general scenario. Whatever sets, doesn't matter. You could have sets of all animals in the jungle, and B is a set of all trees in the jungle. So that is not an issue, right? So to understand mathematics, you should have some general vision. We are talking about general situations, and these real numbers, natural numbers, we can deal with numbers easily because of our previous knowledge. So that's why we find it comfortable with numbers, but otherwise it could be set of anything, right? So let A and B be non-empty sets. uh, Let some B belongs to B be a fixed element, right? So fix some member of B, fixed, right? Then the function f from A to B defined by fx is equal to b for each x in A, right? So you just fix element of codomain and assign all the elements in domain to that fixed element is called as constant function. Constant function, right? And therefore now you can have many constant functions available. You take any set of all students or set of all animals, set of all objects available. That is a constant function. Now uh, the functions which you already studied before, like trigonometric functions.
So,
Yes.
for identity function, the graph will be straight line passing through origin.
Which identity function? Identity function you are
Like
talking.
if we define an identity function, f of x is equal to x. So for one, f of 1 will be 1. So each value of real numbers, it will be a straight line passing through.
But it is a function from R to R. You are talking about this.
Yes, sir.
So when we talk about function, you should mention domain and codomain. Otherwise, it doesn't make sense, right? Because when I say identity function on set of all animals in the jungle, then it is a different kind of thing, right? We
Yes,
understand.
sir.
So f of x is equal to x. Then what is a graph? And first of all, I should make a definition of graph, formal definition. So let me make a definition. So graph of a function. Right? Because in general sense, what is a graph? Because you are most of the times what happens ki you are thinking in the way which you have already seen. and that is not sufficient to generalize the concept. So what is a graph of function? So let A subset of R, we are basically talking about subsets of R, B subset of R, and F is a function from A to B. Okay, let me make general definition and then we'll think about R and all this. So I will make first definition of general function, not R. So let A, B be non-empty sets. If F is a function from A to B, right? When I write F A arrow B, that means F is a function from, then the graph of F is the subset G F of, what can I say about graph? Graph is a subset of A cross B given by, what is the graph of F? Graph of F is pairs x comma y such that y is equal to fx. Do you understand? What is the graph? Is it clear? How do you, suppose in school in 10th standard or 9th standard you did this exercise, key plot the graph of some being. What you did? What you did?
We take the point of x
Suppose
and y and plot the graph.
you are asked to plot the graph of y is equal to x square. That means what is y? You can say that y is fx. And you are asked to plot the graph of y is equal to x square. What do? You take x is equal to 0 and you find value of y. You take x is equal to 1, then you find value of y is equal to 1. If you take x is equal to minus 1, you find value of y is 1. And you, what you do? You plot these points 1, 1, minus 1, 1. Ultimately, what you are plotting? X and x square, right? You are plotting these points. You are looking at the pairs. And then you plot 0 0, then 1 1, then minus 1 1, and then 2 4, then minus 2 4, and then you draw the curve like this, and this is a graph of y is equal to x square, right? Do you remember this?
Yes, sir.
Yes, sir.
And basically what you were doing, you were trying to look at the subset of r cross r, because this x was real numbers in that case, and you are trying to look at subset of r cross r. That means R2, that means plane, right? And therefore basically what is a graph? Graph is a subset of A cross B. And what is that subset? Those pairs. Which pairs? Not all the pairs in A cross B. Which pairs? The pairs x comma y for which the second component is value of function at first component. Is it clear? Right? Is it clear?
Yes,
Can you
sir.
repeat the last sentence,
Yes,
sir?
sir.
So what is a graph? Graph of a function from A to B. Graph of a function from A to B is a subset of A cross B. But it is not whole set A cross B. It is a subset. Subset means what? Those points from A cross B, those pairs from A cross B for which the second component of pair is a value of function at first component. This is what you did in drawing plotting graph of y is equal to x square. So how did you plot the points? You just evaluate what is the second component, y. What is the y? Value of function at x, that is x square. Is it clear?
Yes, sir.
Yes, sir.
Yes.
Sure.
Okay, so you think about it. Next time we'll see more about the functions, right? And we'll see some examples also, because the function is a very essential topic, essential concept in mathematics and every field of science, right? Because in physics, chemistry, electronics, or whatever geography also you come across functions, and therefore you should have some general vision about functions, right? So we'll